Okay, for number 25, it asks you to find what the perimeter of these are. Or first you have to find out if it's isosceles, and you have to find out if it's a right triangle, and then you want to find out the area if it is a right triangle. So to do this, we need to actually find the lengths of the sides. So we're going to start with AB, and we're going to use the distance formula. And so for the length from A to B, the distance is going to be x1 minus x2 squared plus y1 minus y2 squared, which would give you the square root of, well, this is negative 4 squared 16, plus 1 is 17. And then BC, it's going to be 2 minus 1 squared plus 1 minus a negative 3 squared for the y's, since this is a negative 3 here for the y value of C. So that's going to give you 1 squared plus 4 squared, and that is 1 plus 16, which is also 17. So we can answer confidently that yes, this is isosceles, because we got two sides that are the same. To find out if it's right, there's a couple ways you could do this, but the easiest way is to just find this third side and then apply the Pythagorean theorem. And so we look at AC, and so AC turns out to be negative 2 minus 1 squared plus 2 minus a negative 3 squared, and that's going to give you 9. Negative 2 minus 1 is negative 3 squared is 9. This is 5 squared, so it's 25. So 9 squared plus 25 squared, or 9 squared plus 5, 9 plus 25 is 34. So that means we can check to see if it's a Pythagorean, if it satisfies the Pythagorean theorem. If it does, then it's a right triangle. So we do square root of 17 squared plus square root of 17 squared. Does that equal square root of 34 squared? Yes, because that's just 17 plus 17 equals 34. And so this satisfies the Pythagorean theorem. So it is a right triangle. And it's a right triangle that's going to look like this. And so to find the area, we're just going to do 1/2 times square root of 17 times square root of 17, which gives you 17